All right, moving on to the Adept video, we're looking at solution outcomes. So really, all we're going to do is summarize what I explained at the end of the previous video, just in these boxes. So fill in the blanks using the appropriate answers below. Each answer should be used once. So here are my answers down here. There are 6 of them. Where should they go in each box? So when we're solving a system of equations graphically, we have 2 lines and we graph them. When we're talking about the slope, there are 2 possibilities. Either their slopes are the same or they're not, hence they are different. Well, we know that when the slopes are different, okay, we have non-parallel lines. So non-parallel lines. Okay. Well, what does that tell us? It means that there is one solution, meaning there is only one point of intersection. No more, no less. All right. Well, let's look at the other case. If the slopes are the same, okay, well, what have we got here? We could have coinciding lines, or we could have parallel lines. So I'll do parallel first. So parallel lines, okay, or we could have coinciding lines. So in both cases, for parallel lines and coinciding lines, the slopes are the same. But when the lines are parallel, we know that our y-intercepts are different. So there's no intersection. For coinciding lines, yes, the slopes are the same, but so are the y-intercepts. In fact, so is every point on the line is the same as the other. So what does that tell us about how many solutions there are, meaning how many places do they intersect? Well, if they're parallel, there is no solution, because they never meet. Okay. And if we have coinciding lines, well, there are infinitely many points on a line, and each point satisfies the other. So infinitely many solutions. Okay. Start off with 2 lines, determine whether the slopes are the same or not. Okay. If they're not, then we've got non-parallel lines, which implies one solution. If the slopes are the same, we need to determine, is it because they are parallel or are the lines coinciding? So if they are parallel, we have no solution. If they are coinciding, infinitely many solutions. So there we go. All right. So how can we use this stuff to predict a system? So not predict what the solution is, but whether or not the system even has any solutions without actually having to do the work. So without doing any algebra, determine how many solutions exist to the following system of linear equations. Why? Well, if you look at this system, both equations are already expressed in slope-intercept form. But note here, look at the slopes. I don't really care what they are per se. All I'm noticing is that they are different, which tells me automatically that these lines, if I were to graph them, cannot be parallel. So if lines are not parallel, they must cross somewhere, only once. Okay, so I don't need to graph a single thing. There is one solution, i.e. one point of intersection. Okay, why? Well, because the slopes are different. They can't be parallel, which means they have to cross somewhere. So there we go. Pretty simple. All right. Given the following system of linear equations, what value or values of Q will give the system an infinite number of solutions? And then it asks what value or values of Q will give the system no solution. Okay. So here I have a system, and I know everything that I need about the first equation, but the second equation has an unknown number here, and we're just calling it Q. It could be any number for now. And we're trying to figure out, if I want this system to have an infinite number of solutions, what would Q have to be? Okay? Or, as it says over here, what would Q have to be so that I have no solutions? Okay. So there are two methods that we could try. So I'll use method 1 over here. And this is, the go-to method, right? Because for some people, it just makes more sense to express everything in slope-intercept form. So this is going to give me 3y equals negative 2x plus 12. And then I'll just divide out 3. So this gives me y equals negative 2x over 3 plus 4. Okay, so that's the first equation rewritten. Okay, the next one, which I'll do in red, okay, it doesn't matter that I don't know Q. I'm just going to treat it just like some number. So let's solve for y. So this gives me 9y equals negative 6x plus Q, whatever Q is. And then I'm going to divide out the 9, as I normally would. So those 9's cancel, and I get y equals, and negative 6 over 9, that reduces, and you get negative 2/3 x, okay, plus q over 9. Well, I don't know what q is, so the best I can do is just leave it as q over 9. So there's our second equation. So perhaps these equations are now more easily comparable. All right. So look at our two equations. Well, you notice that their slopes are identical. They're both negative 2/3. So we know that this solution can never have only one solution, right? Because the slopes are the same, we either have no solutions at all, or we have infinitely many solutions. Okay, well, if we want, let's say, first of all, we want an infinite number of solutions. Well, that happens when the slopes are the same, which is already true, and the y-intercepts are the same. So that's when 4 and q over 9, when those are equal. Okay, so I'm just going to make a note here. Infinitely many. Okay, that happens when 4 is equal to q over 9. Okay, well, that's a new little equation that we can solve. Just multiply both sides of this equation by 9. So this gives you 36 is equal to q. Okay, and then you can check it. What's 36 divided by 9? Well, of course, that gives you 4. So if q is the number 36, these two lines will actually be exactly the same. So there will be infinitely many solutions. What does q have to be such that there are no solutions? Well, to answer this, it's actually easier than you might think. So no solution. Okay. Well, we already know, because the slopes are always the same, there can never be just one solution. So it's infinitely many or nothing. Okay. Well, if q is 36, we get infinitely many solutions. Well, if q is anything other than 36, any number you want, just not 36. So we could just say if q is not equal to 36. There we go. Okay. So you could experiment, right? What if q was the number 18. 18 over 9, that would give me a y-intercept of 2. So these lines would be parallel, no solution. You can choose any number for q that you want, absolutely anything. As long as you don't choose 36, okay, these y-intercepts will be different. Okay, so that was actually pretty simple to answer. Okay, now I did mention that there were two methods, and this second method is less about algebra and more about just pattern recognition. Okay, so what I'm going to do is I'm just going to leave this equation as is. So I'll just keep that in blue. So this is 2x plus 3y equals 12. Now with the second equation, all I'm going to do is reverse these terms so that they line up with the variables in the previous equation. So this becomes 6x plus 9y, that's equal to q. All right. So in fact, that's all the work I'm going to do. The rest is just observing. So compare each equation. Look at these coefficients. Okay, this 6, that is 3 times as large as 2. Okay, well that is consistent here as well. 9 is 3 times that of 3. Well, if I keep that pattern going, what is 3 times 12? That is 36. Okay, so what that means is, if I take this blue equation and I multiply both sides, in other words, everything, by a factor of 3, I will get the same equation. Okay, it's just the coefficients have been scaled up by a factor of 3. But if you graph the lines, they're still exactly the same. Okay, so because these are all multiples of 3, if I keep this pattern going, if q is 36, as it was here, then I would get the same line, hence infinitely many solutions. If this pattern holds here, but then it breaks here, okay, in other words, q is not equal to 36, I would get no solution.